So in problem 26 from homework 1.1, we're told that this system is consistent for all values of f and g. Consistent for all values of f and g. So we're going to do the one thing that we know how to do in this section. Write the augmented matrix and find its reduced row echelon form. So by columns, the augmented matrix for this system is 2C, and then 4D, and then FG. I'm just going to write down the augmented matrix for this linear system. We can see that we can pivot in the first row, first column. So to get that to be a 1, because I want the reduced row echelon form, because I'm picky like that, I'm going to multiply the first row by a half. So 1/2 row 1, and it becomes, the first row becomes 1, 2, and then half of f, so f over 2. The second row I didn't do anything with, so it'll be C, D, and G. Now that I have a 1 and I've identified my first pivot position, I'm going to use that 1 to zero out the rest of the column. So to row 2, I'm going to multiply, so I'm going to replace row 2 with negative C times row 1, and then add it to row 2. So that's the operation that I will perform. So I multiply this top row by negative C, so it becomes negative C, negative 2C, and negative CF over 2. Then I add that to my second row. My first row stays the same. 1, 2, and f over 2. My second row becomes negative C plus C, which is 0. That's what I wanted. The next column has D minus 2C. And then the last column will be G minus CF over 2. So the last column will be F over 2, and then G minus CF over 2. So we're told that this linear system is consistent for all values of f and g. It might be the case that g minus cf over 2 is all equal to, is not 0. If g over cf, g minus cf over 2 is not 0, then to be consistent, d minus 2c can also not be 0. So if this linear system is going to be consistent for all values of f and g, we have to have a pivot in this d minus 2c location. So the thinking goes like this. D minus 2c, we must have a pivot here. So we're thinking we must have a pivot here. Otherwise, if d minus 2c is equal to 0, then that leaves open the possibility that there's a pivot in the rightmost column. So we must have a pivot here. That is, d minus 2c cannot equal 0. Otherwise, there might be a pivot in the rightmost column. If d minus 2c is equal to 0, then we might have a pivot in the rightmost column of the augmented matrix, and therefore the linear system would be inconsistent. If d minus 2c equals 0, if d minus 2c is equal to 0, then there might be a pivot in the rightmost column of the augmented matrix. Then for some values of f and g, there is a pivot in the rightmost column of the augmented matrix. if d minus 2c is equal to 0, then for some values of f and g, there's a pivot in the rightmost column of the augmented matrix. And therefore, the associated linear system is inconsistent. But we were given that the linear system is consistent for all f and g. Therefore, d minus 2c cannot be 0. Any questions? Any questions? Great.
So actually, I have one question for number 25.
Uh-huh.
And I reduced it all the way to the last row. I couldn't really, I couldn't find the pivot point from that point. Maybe we could work on that last part if we could.
Sure. So on 25, now remember, I took the opportunity yesterday to push the reduced or echelon form. With all these things, like notice that in this problem, in 26, I didn't go all the way to the reduced or echelon form. I didn't divide d minus 2c by d minus 2c and then zero out the 2. I just got it down to a point where I could see where the pivots are or where the pivots needed to be. So let's do that on problem 25. Let's just take it as far as we need to find out where the pivots are. So on 25, we have this augmented matrix. By columns, it looks like 1, 0, -2. Second column is -4, 3, 5. The third column is 7, -5, -9. And the last column is G, H, K. And this is 1, 1, 25. So because of the G, H, and the K, it's going to be difficult to get the reduced or echelon form. Eventually, they're going to have to divide by some weird expressions. So we're told that we want to find an equation involving G, H, and K that makes this augmented matrix correspond to a consistent system. We want this augmented matrix to correspond to a consistent system. So what that means is that we need to make sure that we do not end up with a pivot in the rightmost column. So let's see what's going to happen. First of all, I've got a pivot in the first row, first column, and I'm going to use that pivot to zero out the rest of the column. So I got a 0 here already, so that's good. And here I'm just going to do 2 in the third row. I'm going to write 2 times row 1 plus row 3 as my new row 3. So 2 times row 1 will look like 2, -8, 14, and 2G. My first row will stay the same at 1, -4, 7G. My second row is also the same at 0, 3, -5, and H. My new third row will be 2 minus 2, which is 0, -8 and 5, which is -3, 14 minus 9, which is 5, and then 2G plus K. 2G plus K. So we've got a pivot in the first row, first column. And now that first column is done. We move over to the next column, and we can see my favorite thing. We can see that the coefficients here are just opposites. And it's nice and obvious that the second one, the third row is just a multiple of the first row. So it's going to be easy to cancel these things out. So instead of dividing by 3, since I don't really care about reduced or echelon form because of all this G, H, and K stuff, I only care about where the pivots are. I'm just going to do row 2 plus row 3 as my new row 3. Row 2 plus row 3 is my new row 3. My first row stays the same at 1, -4, 7, and then G. My second row is also going to stay the same, 0, 3, -5, and H. And my third row will become 0 and 0, which is 0, 3 minus 3 is 0. Negative 5 and 5 is 0. And then 2g plus h plus k. 2g plus h plus k. So I'm only performing enough row operations to find out where the pivots are. I don't need the reduced row echelon form. I just care about where the pivots are. Here, we are only concerned about where the pivots are. We are only concerned about where the pivots are. That's why I'm skipping reduced row echelon form and just going for a plain old echelon form. That's why I didn't divide by the 3. I'm going to skip the reduced part of it and just go for the echelon form. So now the important thing has been revealed. This third column is not a pivot column. We do not have a pivot in the third column. So a non-pivot column showed up in our augmented matrix. So if this is going to be the augmented matrix of a consistent system, then we cannot have a pivot here. So in the third row, fourth column. That means 2g plus h plus k must equal 0. Otherwise, the associated linear system will be inconsistent. So the associated linear system is consistent only when 2g plus h plus k is equal to 0. So the associated linear system, oops, I don't want to circle because it's not a pivot column. The associated linear system is consistent when 2g plus h plus k is equal to 0. If 2g plus h plus k is equal to 0, then we do not have a pivot in the rightmost column of the augmented matrix, and therefore the associated linear system is consistent. That is, we would not have a pivot in the rightmost column of the augmented matrix. Any questions?
I have one.
Yes.
So back to question 26.
Uh-huh.
And what if d minus 2c equal to 0 and g minus cf divided by 2, the last one also equal to 0? So you can get infinity many solutions.
That is correct. If d minus 2c is equal to 0 and g minus cf over 2 is equal to 0, then there will be infinitely many solutions.
Yeah.
But we were given that this linear system is consistent for all values of f and g. So that includes, so if we want to guarantee that the system is consistent, then the only way to do that is to force d minus 2c to be non-zero. If we force a pivot here, then we'll always have a unique solution, or we'll always have a solution, which happens to be unique in this case.
All right. Thank you.
Any other questions? How are we doing? Isn't this fun? The answer is yes, this is fun.
I'm sorry, why is, so for number 25, why did we conclude that that 0 is a non-pivot column again on number 25?
On number 25, oh, sorry, that's 26. On number 25, there's no way to get a pivot down here. We can't make this non-zero
Okay.
without breaking these zeros that we already got, right?
Okay.
So this is not 0. And if I start using one of these rows to put something down here that's not 0, then all of a sudden I'm breaking the echelon form that I have over here.
Oh, okay. Makes sense.
So once we move down rows, we don't get to use, once we move across columns, we don't get to use those columns. Or once we start moving down the rows, we don't get to use these rows to get, to change zeros to not zeros, because it'll break our echelon form and we'll start going around in circles.
Oh, okay. Gotcha. Thank you.
Cool. Well, any other questions on 1.1? Cool. Let's stop video here.